We will see some problems from ray optics, wave optics, and electromagnetic waves. So here goes the first question. If E and B represents electric field and magnetic field vectors of an electromagnetic wave, then the direction of propagation of the wave is along. So we know that direction of propagation of the wave is along E bar cross B bar. So fourth option will be the answer for this. Next, a light beam of intensity. So this is intensity is incident normally on a perfectly reflecting surface of sides. So this becomes the area, length into breadth. The momentum imparted to the surface by the light per second is. So momentum of photon is given by E by C. For a perfectly reflecting surface, when the photon falls on this one and it gets reflected normally, change in momentum will be equals to 2 into P, which is 2 into E by C. But as we know, intensity, there is a direct formula. Intensity is energy per unit area per unit time. Energy is replaced by IAT. So this becomes 2 into I into A into T by C. This is the change in momentum when a photon is incident on a perfectly reflecting surface. 2IAT by C. If it is absorbing surface, then it is IAT divided by C. So let's substitute the values. 2 into intensity, actually we need to convert into meter per meter square, but as here we are multiplying, this centimeter square gets cancelled. So 2 into 20 into area becomes 25 into 15 into time is per second divided by C. C is 3 into 10 to the power of 8. So this is 5 times 25 is 125, 125 fours, it is 500. So this one 125 into 4, 500, one more 0, so 5000 into 10 to the power of minus 8. So it would be 5 into 10 to the power of minus 5 kg meter per second. 5 into 10 to the power of minus 5 kg meter per second. Next, a compound microscope has a eyepiece of focal length 10 centimeters, eyepiece focal length, and objective of focal length 4 centimeters. This is f0. Calculate the magnification if the object is placed at a distance of 5 centimeters. Object is placed from the objective. Distance of object from the objective is u0, so that the final image is formed at least distance of distinct vision. That is d. So we know when the final image is formed at least distance of distinct vision, the magnification is with a minus sign, though minus is not given here. So we will go with the v0 by u0 into 1 plus d by fe. Magnification of objective, magnification of eyepiece. Eyepiece can be obtained directly. 1 plus d is 20 by fe. Fe is 10. So 1 plus 2, that is 3. So we got this complete term as 3. For this v0 and u0, take length formula. 1 by f0 is equals to 1 by v0 minus 1 by u0. So 1 by f0 is given as 4 is equals to 1 by v0 minus 1 by u0. u0 is given as 5 centimeters with a minus sign, object. So minus of minus becomes this one. So this implies 1 by v0 is equals to 1 by 4 minus 1 by 5. So 1 by v0 is equals to, LCM is 20, 5 minus 4, this is 1 by 20. So v0 is 20, hence the magnification is 20 divided by u0. u0 is 5, into this we got it as 3. So this is 4 into 3, that is 12. So the magnification is 12. Next, in a Young's double slit experiment, the intensity at a point where the path difference is lambda by 6 is I. If I naught denotes the maximum intensity, then I by I naught is equals to. Similar problem was asked in recent NEET 2026. So here we know the intensity formula I is equals to I max into cos square pi by 2. I max is given as I naught. So I by I naught is equals to cos square pi by 2. Phi is to be found out. Phi is the phase difference. So we know the formula phase difference is equals to 2 pi by lambda into path difference. Path difference is given as lambda by 6. Lambda by 6. So once check, this is pi by 3. Pi by 3. 60. 60 by 2. 30. So 30. Cos 30 is root 3 by 2 whole square. That is 3 by 4. Fourth option. Next. If a transparent medium of refractive index mu 1.5 and thickness T 2.5 into 10 to the power of minus 5 meters is inserted in front of one of the slits of YDSE, how much will the shift in the interference pattern be? The distance between the slits is small d, which is 0.5 mm, and the distance between slit and screen is this one, that is 1. This is capital D. Capital D. So let us now see what is the formula for this. Is nothing but lateral shift. In Young's double slit experiment, in front of one of the slits, if you introduce a transparent sheet, the complete fringe pattern will shift, and that shift is given by T into mu minus 1 into either beta by lambda or T into mu minus 1 into capital D by small d. So this one is T, thickness 2.5. As the options are in centimeters, I will write this in centimeters. So this is 10 square. So 10 power minus, so 2.5 into 10 to the power of minus 3. Then mu is 1.5. 3 by 2 minus 1 is 1 by 2. Capital D is 100 divided by small d is 0.5 millimeters. So 0.5 into 10 to the power of minus 1 centimeters, which is 5 into 10 to the power of minus 2. So check now what answer we are gonna get here. This is 50. Then this is 10. Then this is this one, and this one gets cancelled, 2.5. So 2.5 centimeters. Next, sixth one. In Young's double slit experiment, 12 fringes are observed to be formed in a certain region, certain segment of screen when the wavelength of 600 nanometers is used. So if this is the screen, this is the central bright band, this is some point P. In this region, you are getting how many? 12 fringes with wavelength 600 nanometers. If the wavelength is changed to 400 nanometers, the number of fringes observed in the same segment. So whenever same segment may number of fringes change when wavelength changes, then the formula is n1 lambda 1 is equals to n2 lambda 2. This is because this distance y is constant in both the cases. Y1 is equals to y2. Y is nothing but delta x into capital D by small d. Here also delta x into capital D by small d. Capital D by small d get cancelled. Delta x is nothing but n lambda for bright band. So n1 lambda 1 is equals to n2 lambda 2. n1 is 12, lambda 1 is 600 is equals to n2. We have to find out into this is 400. This and this getting cancelled, 4 1s, 4 3s. So this would be 18. So n2 is equals to 18 bright bands will be obtained. Next, seventh one. In Young's double slit experiment, the slit separation is 1 mm. 1 mm, that is a small d. And the screen is 1 meters from the slit. This is capital D. For a monochromatic light of wavelength 500 nanometers, the distance of third minima from the central maxima. This is central maxima. This point is P. This is Y. As I have written just now, the formula Y is equals to delta x into capital D by small d. we need third minima. So delta x for minima is 2n minus 1 into lambda by 2 into capital D by small d. This is equals to 2n third, 2 into 3, 6 minus 1, 5. 5 by 2 into lambda. Lambda is 500 into 10 to the power of minus 9. 5 by 2. Right, lambda into capital D. Capital D is 1 divided by small d. Small d is 10 to the power of minus 3 meters. So this goes to the numerator. 10 power 5, 10 power minus 4 into 5 is 25. 25 by 2 is 12.5. This is in meters. We want the answer in millimeters. Take 10 power minus. So this becomes 1.25 millimeters. 1.25 millimeters. Next, a single slit width, single slit is illuminated with light of wavelength lambda. Single slit, this is width is A, diffraction mein. The observing screen is 80 centimeters, capital D, from the slit. The width of the central bright fringe will be, central bright fringe will be, this is y and this is also y. So it is width is equals to 2y, which is 2 into y, n lambda d by d. So lambda capital D divided by d. So this happens to be 2 into lambda is given as 500 into 10 to the power of minus 9. Capital D is 80 into 10 to the power of minus 2 divided by small d. Small d is 2 into 10 to the power of minus 4. So you can just check, this is 0.2 to 10 power minus. So this and this getting cancelled. Need not do all 10 powers. 8 5s 40. 4 answer should be in 4. 4 mein answer ek hi hai, so this has to be the answer. Otherwise you can check now again. 8 5s 40, 1 0, 1 2 3. So 4 zeros you are getting. So 4 into 10 to the power of 4 into 10 to the power of minus 11 into again 10 to the power of, this one goes to the numerator 4. So you are getting 4 into 10 to the power of minus 3. So this one. Next, 9th. A parallel beam of monochromatic light of wavelength 5000 angstroms is incident normally on a single narrow slit of width 0.001 millimeter. The light is focused by a convex lens placed in the focal plane. The first minima will be formed for the angle of diffraction. First minima condition, A sin theta is equals to n lambda, minima condition. So n is 1 over here. So sin theta is equals to lambda divided by A. Lambda is 5 into 10 to the power of minus 7. A slit width somewhere. This is 10 to the power of minus 3 into millimeter, 10 to the power of minus 3. So 10 to the power of minus 6, which is 5 by 10, which is 1 by 2. Therefore, 1 by 2 is 30 degrees. So therefore, we get it as 30 degrees. Sin theta, 30. So that is the answer for this one. Sin theta is equals to. Next. A single slit Fraunhofer diffraction pattern is formed with white light. For what wavelength of light third secondary maxima in the diffraction pattern coincides with the second secondary maxima in the pattern of red light of wavelength 6500. Again, coincides means y1 is equals to y2, and as y is delta x into capital D divided by A. So now let us see what is delta x in the first case. Delta x in the first case is the third secondary maxima, and the condition for maxima is 2n here minus 1 into lambda by 2. So therefore this is 2 into n. N is third. 2 into 3, 3, that is 6, 6 minus 1, 5 by 2. 5 lambda 1 by 2 is equals to, this has to be, anyways d by a is going to get cancelled, is equals to second into n2, which one? 1 minute, right, into is equals to lambda 2 ka secondary maxima. So 2 into 2, 4. 4 minus 1, 3. So 3 by 2 into lambda 2. 2 getting cancelled. Let us substitute 5 into lambda 1. Lambda 1 we have to find out. Lambda 1 is equals to 3 into lambda 2. Lambda 2 is 6500. So this one is 5300. So this would be somewhere 39. 39 isn't there. Somewhere something is missing over here. Let me check once. Condition, yes, condition is delta x 2n plus 1, right? So for maximum, so first one 2n plus 1, third 2 into 3, 6 plus 1 7 lambda 1 by 2 is equals to, this is secondary, 2 into 2 4 plus 1 5 lambda 2 divided by 2. This getting cancelled. 7 into lambda 1 is equals to 5 into lambda 2. Lambda 2 is 6500. So lambda 2 is equals to 5 into 6500 divided by 7. Just solve this one. How much you will get? Approximately, you can see, that is 5 into 65. 5 into 65 divided by 7 somewhere. So 4642, right? 4642. This would be the answer for this one. 4642 approx answer. So condition for this maxima is 2n plus 1 into lambda by 2 in diffraction pattern. Next, two Polaroids are placed in a path of unpolarized beam of intensity I naught such that no light is emitted from the second Polaroid. For no light to come from the second Polaroid, these two have to be, this is one Polaroid, this is the other Polaroid. These two have to be perpendicular to each other. Then a third Polaroid whose polarization axis makes an angle theta with the polarization axis of the first one. So first one, this is second one, and third one is placed over here. Is placed between the Polaroids, then the intensity of light emerging from the last Polaroid is. Now if this angle is theta, this angle will be 90 minus theta. Let us apply Malus law. Here the intensity is I naught. So the intensity coming out of the first polarizer will be I naught by 2 into I naught by 2. This one, this is I naught by 2. Now this I naught by 2 is incident over here. The intensity which comes out will be I naught by 2 into cos square theta. This intensity is incident here. The intensity which is coming out, the resultant intensity which is coming out, I is equals to I naught by 2 into cos square theta. This is the intensity which is incident over here on this one, into cos square 90 minus theta. Cos 90 minus theta is sin theta. This is I naught divided by 2 into sin square theta cos square theta. To get the given options, let us multiply and divide by 4. This is 8. So I naught divided by 8 into, this is 2 sin theta cos theta whole square, sin 2 theta whole square, that is sin square 2 theta. Sin square 2 theta. So I naught by 8 sin square 2 theta. You can remember this as a direct formula. If there are three Polaroids, first one and the last one are crossed, second one there is another Polaroid in between, then the intensity of light coming out of the third Polaroid, the last Polaroid, is I naught by 8 sin square 2 theta. This can be remembered as a formula as well. Next, unpolarized light falls first on a polarizer P and then on analyzer A. If the intensity of the transmitted light from the analyzer is 1 by 8th of the incident unpolarized light, then what will be the angle between the optical axis of P and A? This is polarizer, this is analyzer. This is I by 2. This is theta. So this is I by 2 cos square theta. This intensity is given as 1 by 8th of the unpolarized. So this is 1 by 8 of the unpolarized. I and I getting cancelled. So this is 4 times. Cos square theta is 1 by 4. Cos theta is 1 by 2. hence theta is equals to 60 degrees. Theta equals to 60. Next, the magnetic field in a plane electromagnetic wave is given by, see here, magnetic field is vibrating along y-axis and the wave is propagating along z-axis, negative z-axis. Then the expression for electric field is, so we know electric field, magnetic field and propagation are perpendicular to each other, mutually perpendicular to each other. So here y and z are over, so electric field has to be in x direction. In x direction, look for how many options are there. See this one and this one. Now the function, this sine wala function should not change. Again here both are same. But in electric intensity we have E naught, Ex is equals to E naught. So how do we find out E naught? We have the formula C is equals to E naught by B naught. So this implies E naught is equals to C into, C is 3 into 10 to the power of 8 into B naught. B naught is 2 into 10 to the power of minus 7. So this happens to be 10, 6, 60. So 60. This will be the answer. 14th. The average electrical energy density of an electromagnetic wave is given by average electromagnetic intensity. So average electric density, sorry, average energy density, not electric energy density. Average energy density is given by half epsilon naught E naught square. This is the formula. If average electrical energy density is asked, it becomes 1 by 4. So this is equals to 1 by 2 into 8.85 or whatever into 10 to the power of minus 12 into E naught square. That is, E naught is here 50. 50 square is 2500. So if you multiply this one approximately, this is 4.4. 4.4. So here you can see here, this is 25 and 4. 25 fours 100. 100 and this 10 power 4. 10 power minus 12 and 10 power 4 is 10 power minus 8. So approximate answer anyways. Nearly anyways the question nearly is asked. So that will be the answer. Next. In order to establish an instantaneous displacement current of 1 milliampere in the space between the plates of the capacitor of 2 microfarad parallel plate capacitor, the varying potential difference needed is, so displacement current we know it is epsilon naught A by D into dV by dt. This is anyways the capacitance. So ID, displacement current is 10 to the power of minus 3 is equals to C. C is 2 micro. Micro is 10 to the power of minus 6 into dV by dt. This is what asked. dV by dt is asked. Getting this to this side, 1 by 2 becomes 0.5 into 10 power minus 6 goes to the numerator, 10 power plus 6, 10 power plus 3. So this happens to be 500 volt per second. Next, light with an energy flux of, that means this is intensity, falls on a non-reflecting surface at normal incidence. If the surface has an area, this is the area, then the average force exerted on the surface during 30-minute time span is, average force is asked. Force is rate of change of momentum. So change in momentum, just now we have written in the one of the problems, change in momentum is equals to, for non-reflecting surface, it is E by C, and E is written as IA into T divided by C. This is change in momentum. Time comes to this side, so delta P divided by T is equals to IA by C. This is the formula. Rate of change of momentum is nothing but the force. So I is 18 into A is 20 because centimeter square are getting cancelled, divided by C. C is 3 into 10 to the power of 8. So this is 6, this is 120, 120 into 10 to the power of minus 8, which is 1.2 into 10 to the power of minus 6. 1.2 into 10 to the power of minus 6. If this happens to be reflecting surface, you get 2E by C. Next. The average electric field of an electromagnetic wave in certain region in free space is this one. then the average magnetic field in the same region, same formula, EC is equals to E by B. So B is equals to E divided by C. E is 9 into 10 to the power of minus 4 divided by C is 3 into 10 to the power of minus 8. So this would be, check once over here, this is 3. Sorry, plus 8. So this is 3. 3 into 10 to the power of minus 12. 3 into 10 to the power of minus 12. Next, 18. A man running at a speed of 5 meter per second is viewed in a side view mirror. Side view mirror is a convex mirror of radius of curvature 2 meters. So if radius of curvature is 2, focal length is equals to r by 2, which is equals to 1 meter with a plus sign, of a stationary car. Calculate the speed of the image when the man is at a distance of 9 meter. So man ka distance u is equals to 9, which is minus 9. So 1 by f is equals to 1 by v minus 1 by u, sorry, plus 1 by u, mirror equation. So 1 by 1 is equals to 1 by v, this is minus 1 by 9, minus 1 by 9 to this side plus, so 1 by v is equals to 1 plus 1 by 9, which is 10 by 9. So v is equals to 9 divided by 10. We are asked to find out the speed of the image. We know speed of the image is equals to minus of, anyways minus is not, v by u whole square into velocity of the object. This is the velocity. So velocity of v by u, v is 9 by 10 divided by u, u is 9 whole square into velocity of the object. Velocity of the object is 5. So this 9 and 9 getting cancelled, we will be getting this as 5 by 100. 5 by 100 is 0.05 meter per second. This is the velocity of the image. So this is the velocity of image. Velocity of image is minus of v by u whole square into velocity of the object. You get minus over here. Okay. Next. The bottom of the container is a 4 centimeter thick glass slab. The container contains two immiscible liquids A and B. Refractive indices are given and the depths are also given. What is the apparent position of a scratch on the outer surface of the bottom of the glass slab when viewed from the container? Let us take this one onto the next page. There is a container whose bottom is made up of glass. So this complete thing is glass. Thickness is 4 centimeters. This is 4 centimeters. So refractive index of glass is not given. We can take this refractive index as 3 by 2 for glass. Next. Has two immiscible liquids A and B. So A liquid is here, this one is A liquid, and then there is another liquid B. So the thickness of A liquid is 6, this is 6 and this is 8. Then the refractive index of A is 1.4, this is 1.4, 1.3. It is given that there is a scratch at the outer surface. You are asked where will the, what is the question once check. What is the apparent position of a scratch on the outer surface of the bottom of the glass slab when viewed through the container? Through the container, when you see, it appears somewhere over here. So we are being asked to find out the shift. So the total shift is equals to the shift due to sum of individual shifts, and shift ka formula is T into 1 minus 1 by mu, or T into mu minus 1 divided by mu. So let us now check the first one. First one, thickness is of glass, thickness is 4 into mu minus 1, mu is 1.5 minus 1, 0.5, divided by 1.5. First one, plus, I think calculation might be lengthy. The next one, 6 into 1.4 minus 1, 0.4 divided by 1.4, plus this is 8 into mu minus 1, this is 0.3 divided by 1.3. So this is 20 divided by 15, plus this is 24 divided by 14, plus this is also 24 divided by 13. So this is 4 by 3. 4 by 3 is 1.33. 1.33. Then next one, 24 divided by 14 is 1.71, and 24 divided by 13 is 1.84 approximately. So if we add this one, 4, 5, 6, 7, 8, then 7, 7, 14 plus 1, 15 plus 3, 18, 18 this one, then 4.88. Approximate answer is to be selected. 4.88, maybe this one. So this is the answer for this. Next. A student plots a graph between the inverse of magnification 1 by m produced by a convex thin lens and the object u as shown in the figure, u and 1 by m. What is the focal length of the lens that is used? So if you see the magnification formula is f by f minus u. U is negative, so this is plus. Now if we reverse, 1 by m is equals to f plus u by f. F plus f is 1 plus u divided by f. So I write this as 1 by m is equals to 1 by f into u plus 1. This is of the form y equals to mx plus c. Y is equals to slope into x plus c. Just compare y axis per 1 by m, x axis per u. So slope is inverse of focal length. This is equals to slope. But if you just observe from this one, slope tan theta, this one, tan theta is equals to b by c. So this is b divided by c, and hence we are asked to find out the focal length. So focal length is equals to c by b. C by b. This is the answer. Next, 21. A fish looking up through water sees the outside world contained in a circular horizon. So if this is the surface of water, circular horizon, this is the fish, this one, of refractive index 4 by 3. The fish is 12 centimeters below the surface of water. So this is given as h, let us take, and the radius, this is what we are asked to find out. This is r, this is c, the light ray goes this way, critical angle. So tan, we know from that equation we can write tan c is, there is a direct formula also for this one, h by r. And we know that sin c is equals to 1 by mu. 1 by mu for critical angle. So c, this is 1, this is mu, this is under root mu, sorry, just a minute. Sin c, sin. So this is 1 divided by mu. This one is root over mu square minus 1. So tan c happens to be 1 by root over mu square minus 1 is equals to h by r. Check once if this is correct. Sorry, r by h. See the diagram? Tan c is r by h. R by h. R by h. So as we are asked to find out r is equals to h divided by root over mu square minus 1. Substitute the values. H is 12 divided by root over mu square. This is 16 divided by 9 minus 1. 16 minus 9. It would be 7. 7 by 9 under root. 9 ka root 3. 3 goes to the numerator. 12 into 3 divided by root 7. 12 into 3 divided by root 7 c. Next. 22. Two identical thin plano-convex lenses of refractive index 1.5 each, having radius of curvature 20, are placed with their convex surfaces in contact with each other. So convex, two plano-convex, identical thin plano-convex lenses are placed with their convex surfaces facing each other. The intervening space is filled with oil of refractive index 1.7. So this is filled with oil of refractive index 1.7. The focal length of the combination is, so here this will behave as three lenses, one plano-convex lens, other one is a concave lens made up of liquid and plus, so effective focal length is 1 by f is equals to 1 by f1 plus 1 by f2 plus 1 by f3. This and this are same radius of curvature is same. So this is 1 by f1 plus 1 by f2 plus 1 by f1 only I am writing because this and this are same. So f3. So I can write this as 2 by f1 plus 1 by f2. f2 is the focal length of this lens. Now let us find out individually. Mu is 1.5, r is 20. So for this one, 1 by f1 is equals to 1 by f3, both are same, mu minus 1, 3 by 2 minus 1 is 1 by 2 into 1 by 20. So this is 1 by 40. Next, the liquid wala, it is a concave. So 1 by f2 is equals to mu minus 1, 1.7 minus 1 is 0.7 into minus 1 by 20 minus 1 by 20 because it is concave. So 0.7 into minus 2 by 20, that is minus 1 by 10. This one. So therefore now 1 by f is equals to 1 by f1 plus 1 by 40 plus 1 by 40 is 1 by 20. Check once, 1 by 20, and this one is minus, I will retain this one only. So this is 0.7 into minus 2 by 20. So 7 to 14. So this is minus 1.4 divided by 20. So this is 1 by f is equals to minus 0.4 by 20, which is minus 4 by 200. This is minus 1 by 50. So f is equals to minus 50 centimeters. So f is equals to minus 50 centimeters. 1 by f1 plus 1 by f2 plus 1 by f3. Next, a ray of light passes through an equilateral prism such that angle of incidence is equals to angle of emergence. I1 is equals to I2, and this, the later one, is equals to 3 by 4th of the angle of prism. That is I2 is equals to 3 by 4th of the angle of prism. Then the angle of deviation is how much? As we know the formula, I1 plus I2 is equals to A plus D. Equilateral prism, so A is equals to 60. So this one will be 15, 45. I1 and I2 will be 45. So this is 45 plus 45 is equals to 60 plus D. This is 90 minus 60 is equals to D. So D is equals to 30. D is equals to 30. So, okay, this one is the last one. So these are the problems from the optics section and electromagnetic waves. Thank you.